Okay, so we have to do, I mean, this is ugly math, but we've got to do it. This one's a little bit easier, so I'm going to do that one first. We have, okay, the bottom line is that when you add and subtract complex numbers, you have to have them in rectangular form. If you multiply and divide them, they have to be in polar form. Okay, so let's do this easier one first for I3. I have a polar form and a rectangular form. So I've got to switch this to polar form. So so the magnitude of this is 2 minus j is minus 90 degrees. Okay, that's one way to get it. I don't know, I did it in my head kind of. The way I did it is I'm imagining the complex plane, and this is just minus j2, so that's this here. So that's how I knew the magnitude was 2 and the angle was minus 90. But a more analytical way of doing it, if you don't have this picture in your head, is that add the 0 here, because you've got, any complex number really is a real part plus an imaginary part. So in this case, the real part is 0, the imaginary part is minus 2 times j. So you know that to convert rectangular to polar, the magnitude is the square root of the sum of the squares of the real plus the imaginary. So that's how I got the 2. The square root of 0 squared plus 2 squared, or actually minus 2 squared, is 2. And then you get the angle by taking the inverse tangent of minus 2 over 0, which is minus 90. And so the way, minus 2 over 0, of course, is undefined, but if you remember what the tangent curves looks like, you have those asymptotes. So if you're approaching it from the negative side, now I think I've got my graph wrong. I think it looks like that. Anyway, it's minus 90. So now you can go ahead and get the I3 is 0.3032. I'm going to stick it up here. I3 is 0.3032, and the angle is minus 69.8 minus 90. That will give you positive 20.2 degrees. Okay, so that's I3, which I'm going to eventually plug into this equation here. So now I need I2. So that's the other math that we have to do. So what we need to do is we need to add and subtract complex numbers. There's no way around it. You've got to convert it to rectangular form. And it's a pain, but just do it. So to convert to rectangular form, if you ever get nervous and you forget, you have r angle theta, right? R in this case is 0.6064. The theta is minus 69.8. Think of this bracket here as being the symbol C, or the acronym CIS, theta. And what you're doing here, this is cosine plus I sine. So what you're really doing is you're taking r times the cosine of theta plus I, but actually in this case I is j, because in circuits that imaginary number I is symbolized by j because I stands for current. J sine theta. Oops, I forgot. So here we go. So you've got to take the cosine of minus 69 plus j times the sine of minus 69. Okay? And when you do that, I don't have my calculator on me, but I'll tell you that what you'll get is 0.2094 minus j times 0.5691. Okay, that's what you'll get. So when you take 0.6064 times the cosine of minus 69.8, you get this. Then you take 0.6064 times the sine of minus 69.8, and you get that. So it's cosine plus j sine. And then here, you do the exact same thing. You'll get 0.2995 plus j, and then the sine of 66.7 is 0.6954. Okay, all over j10. Okay, so now you can do the math. You can subtract this well, subtract this number from this number, subtract this from this, j is going to be the factor, and you get, what you'll end up with is 0.0901 minus j times 1.12645 all over j10. And then what you can do, it's easy enough to divide both of these by 10. When you divide this by j, then this becomes the real term. 1 over j becomes minus j, right? Because if you multiply j over j, then j squared in the denominator becomes minus 1. You get j in the numerator. So you get a plus j 0.0901, actually. You divide it by 10. Anyway, I know I'm sort of losing it here. But I think I took you far enough that now that you've got your I3 and I2, then you put it back here. And then you got to convert it back to polar form. I know I'm skipping tedious stuff that I just don't feel like doing because I'm tired. Sorry. You can email me if you really can't get it. But this is the final answer for I1. But that's not what this is the phasor form of it. We weren't asked for the phasor form. We were asked for the time domain form. So just finally, the time domain form is going to look like this. It's the magnitude and then cosine 2t, because remember that frequency was 2, plus the phase angle. Okay, and there's my final answer. Email me for questions. Good luck on all your finals. Bye.